Hello students, let us understand the concept of maximum delay of two-phase latch sequential circuits. So you can see here latch L1 is there which is given to a clock signal phi 1. Here latch L2 is there which is given a clock signal phi 2. So over a cycle Tc, two latch is used L1 and L2 which has connected two different clock signal phi 1 and phi 2. That's why it is known as two-phase latch sequential elements or sequential circuits. Now we'll understand what is the maximum delay can be given to the combination logic 1 and combination logic 2 so that we'll get a correct output at the end of these clock cycles. That means T3 should be correct. So that expression will be known as maximum delay expression. Let us understand the clock signals. Phi 1 is given. This is the rising edge. This is your clock is 1. Again falling edge is there. Again the clock will be 1 after that cycle. So from this point to this point it is one cycle, the duration is Tc. Coming to the phi 2, it is 0 here, then it is coming a rising edge here and become 1 at this point. This second phi 2 is given to the latch L2. So in this level triggered 1, this L2 is active. Okay, so now we'll understand what is the delay will be here. I have given the data D1 to the L1 latch. So when the rising edge and the level trigger positive level, that is 1, is coming in the clock signals, the data D1 will be transferred to output Q1, which you can see here. Now data is transferring from D1 to Q1. So they will have two delay time. One is known as contamination delay, where the execution will start. Then after some times the output will be a stable output, that is known as propagation delay. Here the expression is T propagation delay D2 Q1, TPD Q1. Now this Q1 will be used as an input to the combination logic 1, and combination logic will perform its operation and it will take some time, that is known as its delay or propagation delay. After propagation delay it will give the output D2. So this is the D2. So now after this propagation delay means the output D2 will be a settled output. If you are starting here, this is known as contamination delay. Here it is changing, output is changing. So this is the output. After this time it is a constant or stable output. This is known as TPD2. Okay, again this D2 will be given as input to a latch L2 which is in the circuits, which will be active in the positive level of the clock phi 2. So phi 2 is positive here, so it is active, L2 is active. Now whenever given D2, it will be transferred to Q2, so it will take some delay. That delay is known as TPDQ2. That means propagation delay when the data is flowing from D to Q2. Next, this Q2 is given to a combinational logic. Same thing, it will take some delay, that is known as propagation delay. After propagation delay, the data will be a constant or settled data at the output, which is known as D3. So this delay is known as TBPD3. So PD2 is the propagation delay of the combination logic 1, or we can write this is PD1, this one we can write PD2. TPD1 is the propagation delay of combination logic 1. TPD2 is the propagation delay of combination logic 2. TPDQ1 is the propagation delay of latch 1 when the data is flowing from D to Q1. TPDQ2, it is the propagation delay of latch 2 when the data is flowing from D to Q2. Now we'll find out what is the total delay occurring when the data is flowing from D1 to D3. So what is the delay? We can write total delay it will be equal to TPDQ1 plus TPD1 plus TPDQ2 plus TPD2. Okay, so this is the total delay, and this total delay should be less than equal to the total clock cycles, then there will be no errors at the output. That means this value should be less than the TC, which is the 1 clock cycles. TPDQ1 plus TPD1 plus TPDQ2 plus TPD2 should be less than equal to the clock cycles. Equal to means that is the extreme time, the extreme delay should be given to the circuits so that the output will be a correct output, but the delay must be less than TC. Then we will write TPD1 plus TPD2, it should be less than TC minus TPDQ1 plus TPDQ2. Okay, now since we will consider both combination logic will have same propagation delay, so we can write this is 2 into TPD, which should be less than TC, minus if we will consider both latch will have same propagation delay of D to Q, so 2 TPDQ. Now this is the expression for maximum delay of a combinational logic in a two-phase latch sequential circuits. Now this is the delay because of the latch L1 and L2, and this is known as sequencing overhead. So the delay should be less than this value, then only the output will be a correct output. Thank you.